Hello and welcome to a new video on IGCSE Classified Physics Paper 2. In this video, we shall be discussing the topic of heat transfer. We shall begin with heat transfer by conduction. A rod is made half of glass and half of copper. 4 pins A, B, C, and D are attached to the rod by wax. The rod is heated in the center as shown. The pins fall off when the wax melts. Which pin falls off first? So the idea here is to distinguish between good conductors and poor conductors. Metals in general are good conductors because they have free electrons. So the heat will spread in this direction faster than in the other direction. It will spread in the direction of copper faster because copper is a better conductor. So it makes the most sense that the heat will spread fastest to pin C, and therefore the wax will melt and the pin will fall off. So C is the correct answer here. The student suggests some uses for containers made from good thermal conductors and for containers made from poor thermal conductors. In which row are both suggested uses correct? So for a good conductor, it gains and loses electricity easily. It does not preserve the heat in an object. Whereas a poor thermal conductor would be good at preserving the heat of an object. So in the case of a good thermal conductor, anything with the word keeping doesn't make sense because it does not keep anything. It's good at transferring. Conducting means the transfer of heat. So we're looking at something that has transferring. On the other hand, for a poor thermal conductor, it's good at keeping things as they are. It's good at preserving things as they are. So let's just cross out anything that has the word transferring and keep the stuff that has keeping for poor thermal conductor. So as you can see, the correct choice immediately becomes choice D, where the good conductor transfers the thermal energy quickly to a cold liquid, and the poor conductor keeps the hot liquid at a high temperature. So D here is the correct answer. Which processes occur in a metal to cause thermal conduction? So you should know that protons, compared to electrons, protons are very heavy objects. They're heavy and they're slow and they do not move. So proton transfer is definitely a no in all physics topics. Whether we're talking about electricity or nuclear physics or whatever, proton transfer is something that very, very rarely occurs, if at all. So this immediately solves the question for us. We definitely want the choice where proton transfer does not occur. What about the other two? In metals, there are free electrons that speed up the process of conduction. Free moving electrons transfer the heat more quickly through metals. And in non-metals, there are no free electrons, which is why they are poor conductors of heat. And electricity as well, but this is for another topic. What about lattice vibration? This is also correct. The molecules vibrate, bumping into each other, colliding with each other in a sense, and therefore this is another method of heat transfer, and this works for both metals and non-metals. So non-metals as well can transfer heat, but only through lattice vibration. So let's draw a small diagram to illustrate this. So any metal or non-metal, any solid in general, has these molecules. And if we get a candle flame at this end, the molecules vibrate and collide with each other, transferring the heat to the other end. This is what we call lattice vibration. And this occurs in metals and non-metals, but it's very slow. The advantage of metals is that they have free moving electrons as well. So other than lattice vibration, these free moving electrons travel very quickly to the other end. So this is why metals conduct faster than non-metals. So anyway, for the purpose of this question, like we said, electron transfer is correct, lattice vibration is correct, but proton transfer is incorrect. If this were a non-metal, if we had here instead of metal, the word non-metal, we would not pick electron transfer because there are no free electrons in non-metals. This is just something for you to understand. So anyway, C here is the correct answer. A wooden beam is painted part black and part white. The beam absorbs infrared radiation from the sun during the day and loses infrared radiation to the surroundings at night. Which part of the beam heats up more quickly during the day and which part cools down more quickly at night? My apologies, this question should not come under conduction. It should come under radiation, which we shall discuss in this video as well. So it's just in another part of the video, but I'll just quickly tell you that black absorbs heat more quickly and loses heat more quickly than white. So black would heat up more quickly and cool down more quickly, and A would be the correct answer here, but we will explain this in more detail later on in this same video. This was a misclassification on my part, and I apologize. A copper bar and a wooden bar are joined. A piece of paper is wrapped tightly around the joint. The bar is heated strongly at the center for a short time, and the paper goes brown on one side only. Which side goes brown, and what does this show about wood and copper? So first of all, you should know that copper is a good conductor, whereas wood is a bad conductor because copper is a metal and wood is a non-metal. So let's filter out the incorrect choices. So for example, wood is definitely not a conductor. So this is wrong. And this as well is wrong. So we can immediately exclude option A and option C. Copper is a good conductor. So in terms of wood and copper, B and D are correct. So which part is going to go brown first? Which part is going to feel the heat first? Is it wood or copper? You might be tempted to say that the copper will become brown first because it has faster thermal conduction and so on, but this is actually incorrect. It is true that copper will conduct faster, but this is exactly the reason why the part on the wood side will become brown first. Here is why. They are heated strongly at the center for a short time. So what happens here? In terms of copper, this heat, this source of heat, immediately spreads out over the entire thing. So the heat is distributed over this entire section completely. So this part that is supposed to become brown only gets a part of the heat. What about wood? Wood is an insulator, so the heat will not travel through the wood and it will be concentrated here. So which part do you think will become brown more quickly, the blue part or the green part? Of course, the green part will become brown more quickly because all of the heat is concentrated in the green, whereas for the blue, the heat is distributed evenly across the copper bar. So therefore, the wood will become brown more quickly. And we will go with option D as the correct option. 4 rods are made from different metals P, Q, R, and S. The rods have equal lengths and equal diameters. The rods are heated at one end in the same way. The table shows the time taken for the temperature at the other end of each rod to rise by 1 degree. Which metal is the best conductor of thermal energy? Of course, it is the metal that will take the least amount of time for the other end to experience heat and to have a rise in temperature. So since we're measuring the amount of time it takes for the other end to experience a temperature increase, then the fastest is Q, the one with the least amount of time. So therefore, we will go with option B. Metal Q here is the best conductor of thermal energy. Pan is made for heating water on a stove. From which type of materials should the pan and its handle be made? Now, for the handle, we would rather that it insulates heat because we don't want it to become too hot so that we're able to hold the pan. So we want the material for the handle to be a poor thermal conductor. So good thermal conductor for the handle doesn't work. For the pan itself, of course, we want it to be a good thermal conductor so as to heat the food or the soup or whatever is inside, or the water, as per the question. So we want the material for the pan to be a good thermal conductor. And B here becomes the correct choice. The thermal transfer of energy through a copper rod involves electrons. A second process is also involved. What is this method of thermal energy transfer, and what is the second process? Like we said, in any solid, heat is transferred by lattice vibration, molecules bumping into each other. And in metals specifically, heat is also transferred by free electrons. So in the question here, they talked about the electrons. They said it involves electrons. So of course, this is conduction. So definitely not convection. And the second process is lattice vibration, not density change, of course. So therefore, B is the correct answer. And I will remind you that electrons are only existent, free electrons are only existent in metals, whereas lattice vibration occurs in any solid, whether it's a metal or a non-metal. So anyway, B here is the correct choice. On a very cold day, a boy puts one hand on the metal handlebars of his bicycle. He puts the other hand on the rubber hand grip. The metal feels colder than the rubber hand grip, although they are both at the same temperature. Why is this? Well, even though they're both at the same temperature, the metal is a good conductor of heat. So heat flows outside of the body of the boy and into the metal part. However, for the rubber, since it's an insulator, it does not allow heat to flow from the body of the boy into it. So therefore, the correct choice here will be choice C. The metal is a better thermal conductor than the rubber. Next, we move on to convection, which is another method of thermal energy transfer. A cupboard is placed in front of a heater. Air can move through a gap under the cupboard. Which row describes the temperature and the direction of movement of the air in the gap? Well, here is the thing. What happens when we have a heater placed like this here? Well, the molecules of air surrounding the heater are going to experience heat, of course. And when they experience heat, they expand. So what happens when a molecule expands? When a molecule expands, nothing happens to its mass. So the mass remains the same because the mass has to do with the amount of atoms and whatever, protons, electrons, whatever. So the mass itself does not change. However, the volume becomes larger. So how does this affect anything? As you might have studied in a previous chapter, if you've already covered density, the density of an object is equal to the mass over the volume. So if the mass does not change and the volume increases, what happens to the density? Of course, using simple mathematics, if you have a fraction, let's say this was 3 over 5, and then it became 3 over 7, or 3 over 10, or 3 over 20, or whatever. This is a smaller fraction than 3 over 5. I'm sure you're familiar with this basic mathematical concept. Whenever the denominator increases, the value of the fraction itself decreases. So it's exactly the same as dividing 3 slices of pizza over 5 people versus dividing 3 slices of pizza over 7 people. If you're dividing over 7 people, each person is going to get a smaller part. So anyway, as the volume increases, the density decreases. So what happens then? When the density decreases, these air molecules become lighter, so they move up. And they are replaced with colder and denser air molecules that pass through this gap. So what is the direction of the air? And what is the temperature of the air in the gap? So in the gap, of course, the temperature of the air is cool because the warm air already rose up because it became lighter and less dense, so it rose up. So these air molecules here in the gap are colder than the red air molecules, which already traveled up. So we're going to go with cool for air temperature. And as I just told you, the direction of motion of these air molecules is towards the heater. And then when they approach the heater, they warm up and become less dense and travel up, similar to the red molecules. And this way, the heater is capable of heating up the entire room. Let's draw a small diagram to illustrate. If we have a room and we have a heater here, like we said, the molecules close to the heater are going to begin to rise up, and they will be replaced by colder molecules away from the heater. So these will move in this direction. When the air molecules rise up, let's draw them in a different color here, they became away from the heater. They're further away from the heater, so they start to cool down. And then when they cool down, the opposite happens. So when they cool down, the volume decreases, so the density increases, and therefore they start falling down. And this is what we call a convection current. So a heater in a room can set up a convection current by which it warms up the entire room. And this basically is the fundamental idea which we will use to solve all the following questions. For this question, we will go with air temperature cool and air direction towards the heater, because the colder air is going to move towards the heater. So B is the correct choice here. Which process involves convection? Bread toasting under a grill, energy from the sun warming a road surface, hot air rising to the top of a cool room, thermal energy transfer through a copper bar. So, of course, the most similar to what we were just talking about is choice C, the idea of hot air rising. The rest are incorrect, and let's just briefly discuss why each one is incorrect. You have here bread toasting under a grill. So you have a grill, this is very hot, and then you have a loaf of bread under the grill. This piece of bread will never warm up by convection. It might warm up due to other processes of thermal energy transfer. But for convection, we're always talking about hot air rising up. So hot air rising up can never affect the bread in this case. If the bread were placed on top of the grill or even a bit above like this, then we can say that it warms up by convection. But as long as the object I'm trying to heat is below the heater, this idea of being below or under the heater, then convection is definitely not the way to go. What about energy from the sun? We're going to get into radiation later on, but you need to know that thermal energy is not transferable through vacuum except by radiation. So outside of the Earth, around the Earth, first we have this layer of atmosphere, right? And then outside of the Earth, we have vacuum. I think I'm missing an extra U here. Excuse me, I probably misspelled the word vacuum. So in order for light and heat from the sun to reach the Earth, it must travel through vacuum. And conduction and convection have to do with the motion of air molecules or any other type of molecules. In case of convection, it's air. In case of conduction, it's the molecules of the solid itself. So in vacuum, there are no molecules. There is just emptiness. So conduction and convection never work in vacuum. Only radiation does. So this is something important to understand. So choice B is definitely wrong because B would only occur by radiation. We said that C is the correct choice. What about D? D, thermal energy transfer through a copper bar. Of course, we already described this as conduction, not convection. So C here is the correct choice. The air in a room is heated by a heater. The diagram shows the circulation of the air in the room. Which statement about the air that is heated is correct? The air contracts and becomes less dense. The air contracts and becomes more dense. The air expands and becomes less dense. The air expands and becomes more dense. As we said before, the air, of course, next to the heater is going to expand because it's heated, so the volume increases, the air expands. And when it expands, it becomes less dense. Why? Because we said that rho, which is the density, is equal to mass over volume. So as the volume increases, the density decreases. Therefore, choice C is the correct choice here. In a refrigerator, the cooling unit can be fitted either at the top or the bottom. In an oven, the heater can be fitted either at the top or the bottom. Which row shows the best position for the cooling unit and the best position for the heater? So, like we said before, if we have a room, we have a heater here. I'm just going to denote the heater with the letter H. We said that the heater heats up the air molecules around it, and they expand and they become less dense, so they rise up. So we definitely want the heater to be at the bottom so that it allows the air molecules to rise up. What about a cooler, like an air conditioning unit, for example, or the cooler in the refrigerator? It does the opposite. It cools down the molecules so they become more dense with the same logic. We have density equals mass over volume. So when they cool down, their volume decreases and their density increases. So they become more dense, in a sense heavier, so they move down. So we always want the cooler to be at the top, not at the bottom. So therefore, the correct choice here is choice C. Which statement about convection currents is correct? Convection currents occur because when cooled, liquids contract and become more dense. Convection currents occur because when warmed, liquids expand and become more dense. So of course, these are contradictory statements because in both of them, the liquid becomes more dense. And one of them is achieved by contraction and one of them is achieved by expansion. So which of these is correct? Of course, remember the rule, density equals mass over volume. So to become more dense, you need the volume to decrease. So the molecule needs to contract, not to expand. So definitely expand here is wrong. Convection currents only occur in liquids. This is incorrect because like we said, they can occur in gases as well. In fact, most of our examples were about gases, not liquids. Convection currents only occur in solids and liquids. Again, this is incorrect because they occur in gases as well. So the only correct choice here is choice A. Convection currents occur because when cooled, liquids or gases contract and become more dense. Convection does not occur in solids. It occurs in fluids, which are liquids or gases. So A is correct. Why does a balloon filled with hot air rise? Is it because cold air is less dense than hot air? Of course, we know this is incorrect. Cold air is actually more dense than hot air. So B here is correct because the idea is that if we have a balloon and we have cold air molecules outside and we have hot air molecules inside, the hot air molecules expand, so they become less dense, and the balloon rises up. It becomes lighter than the air molecules around it. This is the idea of why a hot air balloon would rise. So B here is the correct answer. Cold air is more dense than hot air. Why is the heating coil of a domestic immersion heater placed at the bottom of the tank? We already mentioned something similar. Any heating element has to be placed at the bottom. Let's read the choices. Cold water is less dense than hot water and therefore sinks. Cold water is actually more dense, not less dense. So this is incorrect. And hot water is more dense is also incorrect using the same logic. So it's either B or C. More dense would rise, would more dense rise. This is incorrect, of course. Something more dense, heavier, would sink, would not rise. So these two don't match. So by elimination, we figured out that C is the correct answer. Hot water is less dense than cold water and therefore rises. A liquid is heated in a beaker. The density of the liquid changes as its temperature increases. This causes energy to be transferred throughout the liquid. How does the density change and what is this energy transfer process? Of course, whenever the liquid temperature increases, we said it expands and the density decreases. So C and D are wrong. And this is called convection, of course. So we're going to go with choice B. Which row shows how heating changes the density of air and the name of the method of energy transfer? Of course, the density decreases and the energy transfer is convection. Similar to the last question. So B is the correct answer here. Next, we move on to radiation. Two otherwise identical cars, one black and one white, are at the same initial temperature. The cars are left in bright sunshine and their temperatures increase. During the night, their temperatures decrease. Which car shows the greater rate of temperature increase and which car shows the greater rate of temperature decrease? So this question is just designed to test one certain piece of information, which is that black is a better absorber and a better emitter of heat. Black absorbs heat better than white and loses heat or emits heat better than white. However, white is a better reflector of heat. So white is like a shield, which is why in hot countries, in countries where it's hot most of the time, the houses are usually made from white. They're painted white, I mean. And they have other architectural features that are interesting. For example, in Upper Egypt, in Nubian houses, they're circular and they're very wide and to allow convection of air. And they're always painted in white to reflect off the heat. So for the purpose of this question, the greater rate of temperature increase and decrease are experienced by black because it absorbs better and it emits better. Which row shows the surface that is the better absorber and the surface that is the better emitter? We just mentioned this. Black is the better absorber and the better emitter. White is the better reflector. So A is the correct answer here. 4 identical metal plates are painted either black or white and have either a dull or a shiny surface. They are heated to the same temperature. Which plate radiates thermal energy at the greatest rate? Like we said, black is the better emitter. Another word for emitter is radiator. So let me just draw a table here. Black versus white. And similar to black and white, we can also use the words dull versus shiny. So anything that is dull has similar properties as black. Anything that is shiny has similar properties as white. For black, we have a lot of different terms. Emitter, absorber, radiator. Black is superior in all of these words. Poor white, it's only better at one thing. It's a better reflector. So in this question, we're looking at the best radiator. So we want something that is dull and black. So A is the correct answer here. A hollow aluminum cube is filled with very hot water. Side X of the cube is opposite side Y. One of these two sides is black and one is white. A student holds the back of one hand 5 centimeters from side X and then immediately holds the back of the other hand 5 centimeters from side Y. Remember that one of the sides is black and one is white. The hand held near side Y feels warmer than the hand held near side X. So which hand would feel warmer? Of course, the hand that is next to the black side, because we said that black is a better emitter. So the heat is inside this object. So if we have black and white, the black will emit much better. So since Y feels warmer, we should know that the black is on this side. Why is this the case? Why does Y have to be the black side? Because it's the greater or the better emitter. So C is the correct answer in this case. This is because the hand held near Y feels warmer. Which statement about infrared radiation is correct? So infrared is another term for thermal radiation, and it's the name of the wave through which planet Earth receives heat from the sun. So the sun sends light and heat to Earth. It transmits light and heat to Earth through electromagnetic waves. There are many different types of electromagnetic waves. One of them is light waves, which we obviously use to see, and infrared waves, which are used for heating purposes, among other things. This is discussed in greater detail in the chapter of waves. So which statement about infrared or thermal radiation is correct? A black surface is a poor absorber. Of course, this is incorrect. A dull surface is a better emitter than a shiny surface. This is correct. We said that dull works the same way as black. Shiny works the same way as white. So black is a better emitter than white. Dull is a better emitter than shiny. So shiny is a better absorber. Definitely incorrect. White is a poor reflector of infrared radiation. Actually, white, the only thing good about white in this context is that it's a good reflector. So B is definitely the correct choice here. The diagrams show 4 spherical objects at the same temperature. 2 of the objects are small and 2 are large. 2 of the objects are white and 2 are black. Which object emits infrared radiation at the greatest rate? Of course, white is a bad emitter. It's a poor emitter. So if we're comparing between B and D, it just makes more sense that the bigger will be a better emitter. It has a greater surface area. There is more room for thermal emissions. So D is the correct choice here. The diagram shows 4 spherical objects of the same color and same type of surface. 2 of the objects are small and 2 are large. 2 of the objects are at the same high temperature and 2 are at the same low temperature. Which object emits infrared radiation at the greatest rate? So this is a very logical question. Of course, the bigger ones are better in terms of emission since they have a greater surface area. And it makes more sense that the hotter object will emit more heat than the colder object. So we're going to go with the choice of the bigger and the hotter object. So C is the correct choice here. The diagrams show 4 spherical objects of the same size. 2 of the objects are white and 2 are black. 2 are at the high temperature and 2 are at a low temperature. Again, for the greatest emission, we're going to exclude the white, of course. and then we're going to go for the higher temperature object. So B is the correct choice here. Finally, we move on to questions that compare the three types of thermal energy transfer. So in these questions, you're going to be required to choose whether the correct answer is conduction or convection or radiation. Thermal energy travels through space from the sun to the earth. Space is a vacuum. How is thermal energy transferred from the sun to the earth? Like we said, the only method by which heat can travel through vacuum is radiation, because it's the only method that does not depend on molecules to transfer heat. Conduction and convection depend on molecules of a medium to transfer heat. So radiation here is the correct answer. The diagram shows a vacuum flask used to keep liquid hot. How does thermal energy pass through vacuum? Like we said, only radiation would work. So C is the correct choice. One method of heat transfer involves energy traveling at a much greater speed than in the other methods. What is the name of this method? As I mentioned earlier, electromagnetic waves travel from the sun to the earth, and these involve infrared radiation, which is the method by which heat reaches planet Earth from the sun. In order to travel such a huge distance and arrive at Earth, of course, they must travel at a very high speed. And we will discuss this in more detail in a video on electromagnetic waves. But for now, you should know that the speed of light, as well as infrared, which is the thermal radiation of heat, is 3 × 10⁸ meters per second, which is basically 300 million meters each second. So, of course, at a much greater speed of energy transfer, this has to be radiation. Conduction and convection do not even compare to 300 million meters per second. So D is the correct answer here. Which types of thermal energy transfer require a medium? So require a medium is the opposite of being able to travel through vacuum. So since we said only radiation can occur in a vacuum, then the opposite is that conduction and convection require a medium. So A is the correct choice here. A girl is outdoors. She warms her hands by holding them near a fire as shown. How does the heat from the fire reach her hands? This is a very important question. Can the heat reach her hands by conduction? Definitely not. Why not? Because for conduction to occur, things need to be touching each other. She needs to be touching the fire with her hands, or touching the hot wood with her hands. So anything that has conduction is definitely incorrect. Would convection work here? Also, no, because convection requires hot air rising up. Remember the example with the bread and the grill? If the bread is above the grill, convection would work. If the bread is below the grill, convection would not work. Similarly here, if her hands were above the fire, if we position her hands here, then convection would work. But as long as the hands are not above the fire, then convection does not work as well. So we're just going to go with radiation only. So D is the correct choice here. A heating engineer fits a heater to the ceiling of an office so that workers in the office are kept warm. How does thermal energy reach the workers below the heater? They love this question. Since the workers are below the heater, then convection does not work. Anything that has convection is incorrect. You might be misguided into reading the word heater and immediately thinking of convection. But convection would only work if the heater is placed at the bottom of the room. If this is where I place my heater, then it can heat up the room by convection. But as long as the heater is placed at the top, convection would not work. So only radiation works here, similar again to the example of the bread and the grill. Aluminum foil is attached to the walls of a warm room in a cold country. This reduces the rate of thermal energy loss from inside the warm room. Which method or methods of thermal energy transfer are reduced by the foil? This is kind of tricky because they did not explicitly state that aluminum foil is shiny in a sense. But the idea here is that aluminum foil is of course shiny. If you ever look at aluminum foil in the kitchen, maybe you're going to find it is very shiny. And that's why it's a very good protector against radiation. It reflects heat and light. So aluminum foil is a method of preventing radiation. And therefore, D, it doesn't completely prevent it. More accurately, it reduces radiation because it's a poor absorber or emitter of heat. So D is the correct answer here. The air temperature in a cold room is 15. A heater that contains water at 50 is used to heat the room. By which process is most of the thermal energy transferred throughout the air in the room? Of course, if we're using water, hot water, and they did not explicitly state that the heater is in the ceiling, you're not going to hang a heater with water in the ceiling. If it's a heater that contains water, it's obviously on the ground. So therefore, the most efficient method here would be convection. Because since the heater contains water, they expect you to understand that the heater must be placed on the ground. So B here is the correct choice. And this brings us to the end of our video. Thank you for watching. I hope this has been beneficial to you.